All right, let's look at the homework 1.1, problem number 6. All right, so we want to find the natural domain of this given function. All right, so let's try that. All right, so remember that there are a couple rules that we always pay attention to. And so first one was we have to make sure that when you have a fraction, the denominator always have to be non-zero, and which we're going to use for this problem. And the second one, if you have square root, fourth root, any eventh root, then inside the square root or any eventh root has to be non-negative. Right. So in this case, we're going to just apply number 1 here. All right, so you can see first, you see a fraction down here. Right, so we have to make sure that its denominator is non-zero. So we have one condition, so we have to make sure that the u plus 4 cannot be equal to 0. It has to be non-zero, right? So we can solve this by simply, just like same as the equation, we try to isolate u. So subtract 4 from both sides so that we have a u by itself cannot be equal to negative 4, right? So one restriction is we cannot have negative 4, right? And another thing is, since if you look at the fraction, you can see that this is actually the denominator of the whole fraction. So we cannot have 0 there. So take 4 plus 4 over u plus 4, right? So we cannot have 0 there, right? So we have that. All right, then what we can do is we try to isolate u from here. All right, so let's see, what should we do? I'm going to probably put 4 on the other side, so let's try that. And subtract 4. So you have a 4 over u plus 4 cannot be equal to negative 4, right? Since it's both a multiple of 4, so I'm going to actually divide through by 4. I like smaller numbers, so divide this by 4, you get 1 over u plus 4 cannot be equal to negative 4 divided by 4 is negative 1, right? So we have that, and then we can take the reciprocal, right? Which is the same thing as raising to the negative 1 power. So take the reciprocal, which is going to be u plus 4, and the reciprocal of negative 1. So 1 over negative 1 is still negative 1. So we can't have negative 1 there, right? Then last thing is you have to get rid of 4 by subtracting 4. So 4, it cannot be equal to negative 1 minus 4, so it's negative 5. So we have to exclude negative 5 as well. All right, so if you have a number line, say that's the entire real number line, and we have to eliminate negative 5 and also negative 4 from the domain. So we can write it in interval notation. You're going from negative infinity all the way to negative 5, and then skip negative 5, and then all the way to negative 4, and then skip negative 4, then you go all the way to positive infinity. Right? So let's type it in. Right, so let's see, the domain is going to be from negative, infinity to negative 5, and then union. So you can use the set notation here. So here's a union, and then you can go from negative 5 to negative 4, right? Then union again, and then go to from -4 all the way to positive infinity. I think there's an infinity under symbol, so you can do infinity there. All right, that's that. All right, so let's check the answer. All right, I came back and looks like we got the natural domain of this function correctly. All right, that's it. I hope that this was clear.